With those who express doubt about God's existence in general, and Christianity in particular, the problem is they don't keep that same skepticism for scientism, or at least the interpretation of scientific discoveries. To expect scientific proof shows a misunderstanding of the philosophy of science. To demand to know something with 100% certainty, especially empirically, is misguided for the following reasons. One of the great contributions to precision and clarity of thought by a mathematician was the Incompleteness Theorem.
And Kurt Gödel certainly belongs in that sort of company. I think the idea of the Incompleteness Theorem, which is what I really want to focus on tonight, is one of the truly revolutionary ideas of modern thought. Absolutely monumental result, one of the major results in logic. Many people have said Kurt Gödel is right up there with Aristotle, and that the incompleteness results were the first major results in logic since Aristotle. So this is really big stuff. This makes it, so as I said at the outset, the basic idea of Gödel's is very, very simple. This is the core idea. A lot of details to get this to work, and the Gödel encoding and so on and so forth, but the basic idea is just ingenious. He'd been thinking about the liar paradox far too long. Far too long for it to be healthy. Now, this is a problem for Hilbert, right? Because Hilbert thought that you could be able to recapture all of mathematics by playing this formal game, where the formal game is just manipulating symbols via rules. What Gödel showed is that there'll be blind spots. You're going to miss bits. If that's what mathematics is, it's going to miss things. Second problem for Hilbert, Gödel's second incompleteness theorem. He showed that no consistent system can prove its own consistency. Modulo a few little caveats here and there, but we won't need to go into details. No consistent theory with a certain amount of mathematics, a certain amount of arithmetic, can prove its own consistency. This is absolutely devastating blow. Because again, remember what was happening at the time. We've got this crisis in mathematics. Mathematics had been proven to be inconsistent. Shock waves went throughout all of mathematics and anyone who used mathematics. This was devastating. We never want this to happen again, was the sort of the mantra. Working out new theories in ways that would never have these sorts of inconsistencies, but no one was completely confident because they thought that the original theory was fine until Russell came along as well. That looked like everything was hunky-dory there, but it wasn't. So while they were hoping that ZFC, the new theory, was consistent, no one was sure. And what you'd really want is a proof that it's consistent. What Gödel showed is, ain't no such animal. There are no consistency proofs, unless it's inconsistent. Then you can have it. But then it's kind of worthless, right? Whereas the Gödel results, these are not kind of things that need to be fixed. These are just facts about the systems. This is just a fact about mathematics. It will have blind spots. You cannot derive the consistency of a system that's rich enough to have mathematics in it within the system. You cannot derive every truth of the system. There will be these blind spots. What are you going to do about it? Live with it. That's why it's such a sort of startling result. These are mathematical theorems about mathematics, or as we're often called now, meta-mathematical theorems, about sort of a layer above mathematics. And we just have to come to terms with them. So they're very, very important very, very important implications for all sorts of places, like mathematics and logic, obviously.
I had a math professor while I was attending Tufts University when I took Introduction to Abstract Mathematics. And we were at the point in the course where we were getting into set theory. And she mentioned Gödel's Incompleteness Theorem. And she also mentioned that when she understood what that theorem was communicating, she said she was devastated. The professor mentioned that she viewed mathematics as her religion. She came to the point where she understood that in mathematics there be statements that cannot be proven true. She said she was actually really shaken to her core. She even offered an extra credit assignment for the students in the class that at the end of the semester they could hand in a brief report just kind of explaining the meaning of life. She did that because she understood that the incompleteness theorem and its consequences was not just about set theory or the set of natural numbers or the set of real numbers, but it had real metaphysical consequences for life in general, just a part of the human condition.